Now, let me call your attention to the graph below, or the signal graph below, which shows how much actual load is absorbed or available from the P available. So P available stands for the total available power at the receiver. Now, at the receiver, you find that most of the power will be matched, but some amount of power will get reflected. So that is considered as a loss. Further, when we go from the matched source, you go into the load. When you do rectification, there is some amount of rectification loss that happens, and then it further passes through as load. So effectively, the total amount of power received or harvested, which is called P load, to over the P available gives us the efficiency of energy harvesting. So this energy of harvesting can be done by using, assuming that the power input or the impedance at the input of the matching network is given as Zin equal to Rn plus Jxin, where Zin is the impedance, Rn is the resistance, and Xin is the reactance. Our aim is to try and reduce this Xin to 0. Now this can be further sent into the rectifier, and the rectifier effective impedance can be again looked at. Impedance of the rectifier is equal to resistance minus Jx, or the minus the reactance value. Now this final value will get cumulatively present at V out DC, which acts as the supply or the load current or the load supply to the end. And when the load is not present, all the energy can be stored into an energy storage device. So this is how the energy gets harvested in an RF system, and you understand where is the efficiency. Now, if you look at what are the places that you need to do, or things that you need to change to ensure you get high efficiency, those are: try and make the P reflected, P close as to 0, and the rectifier loss to be as close to 0. So to make these two 0, you need to tweak, design, and understand the new challenges that the programmable matching networks and the multi-stage rectifiers give, and how do you get the appropriate inputs. But one thing you need to understand, that if the load required is much more than the available load, then you need to duty cycle. What is duty cycle? Duty cycle is the amount of on time or the active time as compared to the harvest time. In this particular case, the duty cycle on time is given as activated load time, and the total amount of time wherein the system is working is harvest plus active load. So the duty cycle can be described as active load over harvest time plus active load. So in this case, what happens is the upper limit of the VDDH, or the useful storage area, or the voltage, depends on what is the storage capacitor present. Storage capacitor acts like an energy storing system, which stores half the where the amount of energy stored in the capacitor is given by half C store VDDH minus VDDL whole square. So V square is a typical understanding of what is the power requirement. So the power requirement, whatever the power that is present in the lower limit to the upper limit, is where the total power can be used, and power integrated over time gives you the energy. So the area under the graph, that is the between the red triangular like value graph and the two black lines, gives the area under the graph, and this is the total energy present in the system at here. So the triangular spaces is all where that you can harvest or accumulate the energy, and the places where there is a sharp discharge is where the load operation happens and the energy is released. So this is the upper edge energy, and this is the baseline energy. Baseline is given as half C store VDDL whole square. So, but important point that you need to consider with regards to what is the storage value, storage cap. So the smaller the storage value, higher the VDDH. Okay, so you will see a higher leak also, and efficiency also be lower. In essence, what we say is, if the capacitance is smaller, this triangle will be more centered across one, and when the capacitor is almost 0, all the peak energy will be centered across one particular instance. So instead of having at one particular instance, we will have it spread out so that we can use it and store it for a longer duration.